In this video, we're going to do the following problem, which says simplify, use absolute value notation when necessary. So first, let's explore why we might need absolute value notation. So let's say we're taking the square root of x squared. We're going to try this out with a couple of different values for x and see why that absolute value notation is needed. So let's say that we're taking the square root of 3 squared. When we square 3, 3 times 3 gives us 9. And if we were to use our calculators to find the square root of 9, we would find that it gives us 3. And by the same hand, if we take the square root of 3 squared, negative 3 times negative 3 is equal to 9. And if we take the square root of 9, we also get 3. Now, you might be saying to yourself, why is this value here 3 and not negative 3? And it's because square roots are defined to be positive values. It's the positive value that I can multiply by itself to get the number that was under the radical. So whether or not we start off with a positive value and square it, or start off with a negative value and square it, and then take the square root, we still get a positive value. And that's kind of like what absolute value does. So when we take the square root of x squared, if we're not told that we can assume that all variables are positive, then we need to say that what we're getting is not x, but the absolute value of x. Okay, so now going back to our original problem, we're going to simplify and use absolute value notation when necessary. So the first thing that I can do is I can split this up into two square roots, the square root of 64 and the square root of x squared. The square root of 64 is going to be equal to 8 because 8 times 8 is equal to 64, and the square root of x squared is equal to the absolute value of 8 as we just discussed. I hope you found this helpful.